Hi, so today we are doing merge two sorted arrays. So we are given A and B array and we have to merge them. And after merging them, they should be like sorted. So C should be sorted in sorted order. So one solution is we uh, get A and B in C and then we sort the C and return C. So this is an inefficient approach. And the second is we we basically perform a merge sort like operation. We will do merge sort in a later video, but I'll explain it to you like what is happening in this case. So we basically take the smaller element from A or B, and then yeah. So basically, if the first element in A is smaller, then we take that. Otherwise, we take element from B, and then that's how we take all the elements from A and B. So let us understand this. Okay, so 1, 2, 3, 4, 4. B is 2, 4, 5, 5. So, like even if I have to form C, I have to perform like that algorithm kind of operation. So even for demonstration, I'm like using algorithm. So just see that one is smaller, so we take one. Then we can take either of them. So we take two, and then we have two. Then we take three. Then we take 4, then we take this 4, then we take 4, then we take 5, then we take 5. So this is what we did to basically get all the elements in C and they are in sorted order. Okay, so the first naive approach is like very simple, and that what we do is we just store all the elements from A and B into C. There is just one tricky thing that we do here, which is like we take the length of A and take that index. Let me explain it to you. So let's say uh, C is here, right? So array is let me take like easier example 1, 2 and B is 3, 4. Let 3, 4, 5. Let's say 3 length. So C would be of length 5, 0, 0, 0, 0, 0. Right. So Ci is equals to Ai. So for in the first loop, what we do is we just initial like all these elements in A are transferred to C. So 1 and 2 are here. Then for transferring elements of B into C, we firstly so I would be 0. I would go from 0 to 2. 0, 1, 2 because length is 3. So in this we add the length of A. So 2. 2 is added in each, right? So it becomes 2, it becomes 3, it becomes 4. So basically what we are doing is, right? So we are accessing second index of C and initializing B here. So this is the second index, right? 0, 1, 2, 3, 4th index. So second index is this. So here we initialize 3. Then we go on to and see we initialize the third index. This first of B, for value at first index of B. And then at fourth index, we initialize value at second index of B, 5. So this is how we initialize C. And then after we have initialized C, we just sort it. Actually, in this case, like A and B. So C came to be sorted. We didn't even need to sort it. But let me show you another example of it. Okay. Assume that B was 1, 2, 5, 5. Uh, it is the 3 here. 3, 4. Okay. So in this case, what we will do, we will have C 0, 0, 0, 0, 0, 5 times, because array of length of A is 2, length of B is 3. So this should be of length 5, which we do here. We initialize C as 0, 0, 5 times. Okay. A is like shifted here, so A would be present in C after the first loop. Here, what we do is length of A, so 2 plus 0. So we are accessing the second index of C. We are assigning the second index of C with the element of at 0 of B. So 1 would be here. Then in the next step, what we do is we do 2 plus 1 is equal to element. So C of 2 plus 1 is equal to B of 1. So C of 3 is equals to B of 1. So at third index we place element at first index of B. So here comes 3, then here comes 5. So C now contains all the elements of A and B. And now we sorted, so 1, 2, 3, 4, 5, and this is returned. So this is what we wanted, like we have to combine A and B and return them in sorted form. Right, so this is the first method of solving this problem. Uh, this sorting operation is costly because this sorting, this generally the time complexity of sorting is n log n. N log n. If you don't know like why it is n log n, I'll explain it later in next video. But oh yeah, so right, so n log n is the time complexity, and we combine this a and b array into it. So c becomes the length of c becomes length of a and length of b, right? So if length was a was 2, length of b was 3, so length of c will be 5. So 5 log 5 is the time complexity. So we just write here like time complexity is big of m plus n. So m is the length of A, n is the length of B. So m plus n log m plus n. Okay. We don't take space, so space complexity is a 1. There is a better approach of solving this with the time complexity of m plus n. Okay. So let us understand the solution. Okay. So in this solution, what we do is, let me explain you the intuition behind the solution first. So A was 2, 4, A was 2, comma 4, and B was 1, 3, 5. Now, if I ask you like, what your like common sense says, like how would you merge them? You will say that I will pick the smaller element first from B. So one is smaller. I'll place it here. Then I will ask this question like now since one is taken, now which element is the smallest? We'll say that element in A is the smallest. So we take that. Okay. Then now we are here. Okay. Now between 3 and 4, which is the smaller? We say 3. And we move like this line. So this line was here. Now move this here. Now we ask this question, which one is smaller? Say 4. So This line comes here. So now we say 5, right? So this is how we'll perform the merge. So this is the intuition. This is what we do in code also. Also, we just initialize the pointer here and initialize the pointer here and pick the smallest of the two, right? Let me just even show you again like how the pointer based approach works. Now we initialize I at 0 and j is at 0 and I is ran across A and j is ran across B and k pointer is at 0 and it is ran across at C, right? So wait, we have IA, IB, IC. Okay, so you can say that this is IA rather than G, it is IB, IB, and this is IC. So index C, you can just say it like that. So they both have they all of them are initialized at 0. Now we compare if array of I is less than array of B of IB. So if this element is less than this element, we have to take element at AIA. But since that is not the case, so we can just take the element at BIB. So we take the element of B in C, okay, and increment this by 1 and increment this by 1. So IC is at 1. Index that is tracking C array is at 1. Okay. Now we compare. Let me just make it like a bit easy for you to understand. Let me explain it again. This is the array A, which is which is 2 and 4. Array B is 3 and 1, 3, 5. Okay, so IA is here. So, so all of them are initialized to 0, right? Initial value of IA, IB, and IC are all 0. You can see all three are 0. We compare element at A index AIA, right? So which is 2 with this element at BIB, which is 1. But which so this condition fails. AI is not less than BIB. So we basically take the smaller of these two, right? So we take B. So we take whatever element at IB is in the B array, we assign it to CIC. So C, we assign it to C, and we increment this one by 1 and this one by 1. Okay, now element at AIA and AIB is compared. So between 2 and 3, which is smaller. Since this is smaller, see we assign in C the element at AIA, which is 2, and we increment this pointer by 1 and this pointer by 1. Now we check now between 3 and 4. Which one is smaller? 3 smaller. So we increment pointer B by 1. We firstly assign this 3 to C. Then we increment this one and this one. Now we compare between these two, BIB and AIA. AIA is smaller than BIB, so we take that. So we assign to CIC this 4. So C of 3 becomes AIE, which is A1, which is 4. We increment this by 1, this by 1. Right. And then now, since AI has exhausted, and these are in sorted order, the elements in B are in sorted order, right? So you can just place all the elements in B into C. So this 5 just comes here. In this case, there is only one element. Let's see if there was a 6 here. B was not ending here. So at fifth index, we would have 6. Like we take the whatever is present in B, we just assign it to C. We can see like these while loop perform that function. So if some elements in present in B and so this loop has exited because of exhaust element exhausted at A. So A array has no more elements. So in that case, we just run this while loop and assign all the rest of the elements in B to C. Okay, so this is the merge sorted array solution. Bye bye.